And today we talk about probably the most important part of a functional language, which is functions. So today we cover this big cell here, and I don't know if we will be able to cover it entirely in its entirety. There is a lot to be done. Since we are not covering as much in this semester, I put more examples, so we're going to go slowly today through these examples. Most likely you guys will fall asleep. Try to stay awake. This is really important, okay? So, functions. There are a number of ways. In Mathematica, anything can be done in multiple ways. For now, I show you how to define functions this way. Then maybe today or maybe on Thursday, I will also show you how to define pure functions, so functions without a name. I forgot to say, the assignments I will probably assign it next week, but I will give you on Thursday, I will give you some exercises for you to just, try things out. If you want to do them well, I recommend you guys do them, but it's not that it will be graded. Let me quit. Delete all outputs. Yes. Okay. So this should be 0, 1. Very good. So function definition consists of 4 pieces, 4 parts. A name, in this case it's f. Then the square brackets, those are fixed, so I don't count them. They have to be there. Then there is one or more arguments, and you see that's the variable x. The underscore, you know already what that is. It's a pattern. Then there is an assignment. You already have seen this kind of assignment. It's a delayed one. It's not the immediate one. And then on the right-hand side, there is the definition. And the definition may or may not use the argument. In this case, I'm using x. X was my argument, so these 2 variables are bound to one another. When I evaluate a function, even if I don't have a semicolon, see, I didn't put a semicolon, I evaluated it and I didn't get anything. I didn't get any output. So the function definition doesn't return any direct value. When I go and evaluate f of 3, now I would like to get 9, and I do. And when I evaluate f of a, I will get, very good, by now everybody believes in symbols. We're happy with symbols, we're pretty comfortable with them. How about the square of a list? In this particular case, I will get a square of every entry. It's not that easy to see why this is happening. This is related to the properties of the operator square, power. If I look at here we go. If I look at the attributes and the options, properties of the power function, I see that it's listable, so this means that it will be automatically mapped to all the elements of a list. This is not so important. But don't be surprised if some of these functions are mapped, are distributed over a list, and some others are not. In this particular case, it is. Okay. What are we going to get here? Okay, that's an answer. Other answers? Sorry? Ooh, you're courageous. We have not gotten a single error yet from Mathematica. So we have 9b squared, we have error.
We have a new function of 3b.
And we have 3b. I like this last best. So the answer is nothing. It's f of 3b. Why is it not 9b squared? That's actually a very reasonable answer, but it doesn't work like that. Because in our definition, we said there is going to be a variable, one variable, and now we invoked f with two variables. And x underscore, so the pattern x doesn't match two variables. That's why it didn't evaluate to 9b squared. We didn't get an error because there is nothing wrong with invoking a function like that. You know, why would we get scared? We simply don't evaluate it. We left it like that. We leave it like that. So that's perfectly fine. All right. If we look at what f is like, it simply says takes one variable, only one, any type, there is an underscore, and returns that variable squared. Okay. Now I want to show you how functions can be invoked, called in Mathematica. We have many different ways. The first three ways are identical. It's how to call a function on one argument. Notice that it's a singular argument. And this is a way of calling a function on two arguments, and these actually are for more arguments as well. So let me show you. If I evaluate this cell, who believes I'm going to get an error? No errors. I will evaluate the function fun on some arguments, and the arguments are unknown, but that's fine. They're just arguments, arg1 and arg2. So the first three cells, the first three entries, all evaluate to function of argument. This is the standard notation. This is the prefix with at the argument. This is the postfix, as I said, if you think as a post-processing step. Okay, and then we have 4 evaluations for 2 arguments, and you see all of them result the same. Function with 2 arguments. This is the infix. I don't even know why you would use this. You use this if you have a plus, minus, times, but that's about it. Apply. This works for more than 2 arguments. Basically, it takes this list of arguments and then invokes function with them, and the same is true for this. This is just a shortcut for apply. Okay, so one of the challenges, just a fun challenge, will be to come up with the shortest program that you can. So these shortcuts will come in handy. All right, here I just want to show you how the same object can be computed in 3 different ways. So if I integrate some function, this is a definite integral, I get some expression, but I'm not so happy about it because, okay, this is symbolic and I don't get some tangible idea. So I want to evaluate this object. And how do I do that? With the function n. We know that already. And here are 3 different ways, and I get 3 times the same story. The next example is as a comparison with MATLAB. Remember that in MATLAB you cannot create a matrix and immediately access it. You have to create it, store it, and then access it. Okay, conversely here you can nest all things that you can think of. Let's see what we have here. Table up to here. This is a 2-dimensional table. It's a 4x3 matrix. Each entry of the matrix is a sign of something. It's not going to be evaluated because these objects are exact so far, and if I evaluated them, I would get something approximated, so Mathematica doesn't approximate them. To see that it's a matrix, you can look at this. Okay. That was just the table bit. Next, there is a square root, not really. First, I access the second entry of that table. Do you guys remember what the second entry of this object is? The second row, yes, in Mathematica the matrices are stored by rows. So this one up to here is a sine of 1/3, sine of 1/4, sine of 1/5. Then I have a square root of that thing. A square root is also listable, so I'm computing the square root of the second row. Notice that the square root of that is a symbolic entry still, it's left unevaluated. So this only adds a square root. I don't get any number yet. But then I want a number, so I apply the n function down here. All right, so at this point I actually have numbers. And then I access the third entry of that thing, which is square root of sine of 1/5. And of course, you could have accessed that entry and computed it in many different ways. I just showed that you can mix all these accessing, creation functions in any order you want. Okay. Now, here is the problem. I want to define a function that does different things on different types of arguments. Let's say that we decide function is g. If the argument is a real number, then we just want to return that number, so identity function. If g receives an integer, then we want to compute the factorial. And if it receives a list, then we want it to speed out the length of the list. Is this function ever going to be used? No, absolutely. This is a totally idiotic function, but I just want to show you how to do it. I think most of you, or probably all of you, will immediately think of the case instruction from Lisp, from C, or the if statement. Okay, in Mathematica we have the switch statement. What does a switch do? It takes an expression, it evaluates the expression, so that's the first argument, expression, it evaluates, and then it starts comparing this expression with the value that you provide. If the two values match, then it returns value 1. If not, it goes on and compares with another value, form 2. If they match, spits out value 2, and so on. So, we could say we define our g. All right, so far so good. Remember, in Mathematica, you can easily break a line, no problem. Everything is connected together. Then I start with a switch. I look at x. And for sure you remember that head tells you the type of 3, 4, 5. And how to see that full form. So head is the 0th entry of every list. And it's also the 0th entry of every expression. So you can access an expression as if it were an array. The 0th entry is the head, and it tells you the type of the entry. Just to give you an idea, I think. Okay, no. So what you do, you extract the head of x, head of pi. What do you think this is going to be? Okay, let's start easy. What do you think this is going to be? No double. In Mathematica, there are reals, so it's a real. This is going to be an integer. Okay, how about this? Mm. Oh, you're cheating. It's a symbol. Okay, so we have our switch statement. We take head, we evaluate the head of x, and then we start comparing. If the head is an integer, we said we wanted to compute the factorial. Okay, good. If it's a real, we just spit out the identity. Okay, if it's a list, we compute the length. Then I put an underscore. Underscore means anything else. Underscore means I'm going to match. If I didn't match any of these left-hand sides, then I will match this underscore. So it's sort of a stopping criteria. At that point, I say, okay, this is something else. It's none of the above. And then I'm not quite sure how I want this function to behave. I can make it abort if I want. I can return hold of g of x. I'll get back to this later. Or, maybe I just do nothing, just return nothing. Okay, let's evaluate this. This is clearly a real number, so I'm going to get the real number. This is a symbol, so I'm going to get, yes, something else. What I'm going to get here, 24, 120, okay. I don't know the factorials. How about this? 4, yes, it's a list, so I'm going to get the length. Something else. That's a string, so how about this? X is just a variable, it's not defined, I don't think. So it's going to be something else. Okay. This is how you guys would have done it, and this is how not to do it. Instead, here is the better way of doing it. So we use patterns, and we use patterns with data type. So let's clear our function. And now we say, if x is a real number, now I am constraining my pattern to be a real number. I just attach the string real to the pattern. Then x. This pattern here now only matches real x's. Now that matches only integer x's. This matches only lists. Okay? Yes? Sure. Yes, absolutely. You can say overloading, you can say polymorphism. Yeah, that's exactly what it is. Okay, so what is g of x? Sorry? Very good. It is g of x. And this is why this is so much better. Now I'm not going to get a abort or a print statement or God knows what. G of x stays g of x. We don't try to define more than what we want. The previous definition, we were actually covering the entire domain of variables. Over here, we only covered those types that we're interested in. And if we go outside of that domain, our function stays unevaluated. That's exactly what the function should do. G of pi, is this going to be pi or not? It's not going to be pi because pi is a symbol, it's not a number. Of course, g of n of pi, this is going to be a number. Okay. These are the basic types available in Mathematica: integer, real, complex, symbols, and list. Now let's get into something a little bit more delicate. We define a function, f of x, sine of x over x. I show you how to plot a function. I will talk about plotting later on, but in Mathematica it's very easy. You just pass a function with an argument, and then you bind the argument on the right-hand side with a something that looks like an iterator. It's just a range. And Mathematica spits out the plot by itself. You don't have to say how many samples, you don't have to say anything. Just to specify the range, everything comes out. Why am I plotting this function? To show you that the function is perfectly defined, has no singularities, nothing, or at least it looks like. But in reality, f of 0 is not very it's not very easy to evaluate. Sine of x over x. So how can we solve this problem? How can we avoid, how can we remove this singularity out of a function definition? So this is my function definition. As I said, the function is perfectly well defined. It's just that in 0, if I place a 0, I get some nasty expression there. So I could do the following. I could say, in addition to this definition, I can say, look, if you happen to evaluate f in 0, without any patterns, this means exactly in the point 0, then just return 1. You don't like it. Okay, why not?
Because we have to do it for every plot that if we have a function that has a lot of discontinuities, then we have to define
I perfectly agree with you, yes. But let's say that we only have one discontinuity. This is not even a discontinuity. This is just, it's not even a singularity actually. It's just a point in which if you evaluate it point-wise, you get an indeterminate value, even though it's a 1. The limit is 1.
Because also it didn't solve the mathematics first, then presented the answer, it solved the logic first, which is dividing by 0 is because it has to be by logical.
Okay, so you don't like that, and then here is what I give you instead. Let's define our function in 0 as, just look at this, a limit of that function with x that goes to 0. First is just because the limit returns a list, okay? So that, forget about it. Basically what I'm saying is instead of the function itself in 0, take its limit. And I also want to show you that the limit doesn't present any problem. It works perfectly. It gives 1 as it should be. So first of that gives 1. And now I'm defining f of 0 to be that. Anybody has some complaint or some comments? Yeah.
We define f of 0 after we define f of x, and I think it matches first f of x and doesn't feel that there's another definition.
Ah, very, very interesting. I like this comment. Yes?
What we're really trying to do is not define sine of x over x, but we're trying to define the limit of sine of x over x. So why should we treat 0 differently? Because what we really want is the limit of f. We want, if we call f, we want the limit. We don't want the limit only if it is 0.
Yeah, okay, this is more philosophical. I am telling you that we want to define f of 0. And I want the function in 0 to be 1, not to be indeterminate. Because it's not indeterminate. It's a 1. At least the limits are 1. I like very much your comment. So now that we have defined f of 0 like this, let's see what f of 0 is. Actually, your comment didn't apply. So what was his worry? He said, we have defined f of x first and then f of 0 later. So now that I call f of 0, this 0 will be matched by the general pattern, x underscore. And so even though I have a definition for 0, it will not be matched. It will be replaced by the general one. Actually, Mathematica works the other way around. It realizes that f of 0 is less general than x, and so it tries to match this first. It's smart enough to do this. And I will talk about orders in a little bit, in a little while. My comment is, do you guys remember? Okay, this is, do you guys remember the difference between delayed assignment and instant assignment? So, do I really need a delayed assignment in 0? It's, after all, it's a constant. I'm saying whenever we ask f of 0 and we are telling Mathematica to evaluate the right-hand side. So, even worse would be to do the following. Clear of f. So we define that, and then we define this. Now if I ask what f is, look at that. Every time I call f of 0, I'm actually evaluating all of that. Do I really need to do that? No. All of this expression is a constant. So I can have f of 0 equal 1. Here you go. Or, if I don't know what the value is, f of 0 equal limit and blah, blah, blah. Then I take the first. This means the first entry of the limit. But the moral of the story is that I don't need the delayed assignment. I can just have a fixed value for that. In that case, I would have a function that has some fixed values, like this one over here. This would become a fixed value. And then it would have a delayed evaluation for all the other cases. I will get back to the order of the definitions in a little while. Okay, let's switch to a different function. Now we are working with h. H takes two arguments, x and y. Notice I use two different letters, and what do? I add x and y up. Okay, so now I want you guys to try and guess what's going to happen. So, h12, how many believe that it's going to be a 3? I have some believers, yes. Next, 4? Yeah. Next?
List of 4.
List.
And the 4 in there. It's the same H2,
So we have two opinions already. I think even 3 of them. Somebody said 4, somebody said 4, somebody said unevaluated H2.
2 plus.
Aha. 2 plus 2. Okay, so in reality not all. This one I don't like, but these two, they actually both make perfect sense. This one I don't like because where did the list go? It disappeared, so it's clearly not going to be that. We're going to have one of these two. If this was the case, I would get an error because I cannot add the two lists of different shapes. But in this particular case, Mathematica will return this because it's a scalar plus a list, and that's a different property of the lists. It's a property of the plus. And when you have a scalar and a list, it will add the scalar to all the entries of the list. So in this particular case, I will get a 4. How about here? I said it, same story. It will add the pi to each entry of the list. So I will have 1 plus pi, 2 plus pi. How about the next one? Oh, I see. So it transforming plus to union or concatenation. Yeah.
I think you said the answer already because scalar to the list, fine, but if we have to add two lists, they have to be of the same size.
That's true, I actually said it already. This is the first time, I think, no, the second, we just saw an indeterminate, but that was a warning. This is the first time Mathematica will give an error, even though it will still return the expression list plus list very much in this type, in this manner. Over here, I will tell you already, we're going to get 2, 4. And what about this? You guys can tell me the answer. Yes, we just get this expression back. Here we go. So we did get an error, and it's pi plus 1, 2 cannot be combined. So effectively, it leaves them alone, but it doesn't like to deal with these kind of objects. That's the way plus is defined. Of course, you can define your own plus, and this would be a perfectly acceptable. So everything 4, as I told you, that's what happened. Everything as predicted, okay? This thing is left unevaluated. Oh, look at that. There is a comma. Okay. So far, so good. Now, second definition of h. Remember, h so far, hxy returns x plus y. Okay. Now I define hx. I didn't clear the definition of h. So hxy is still active. And now I have defined also, I have added this second definition, h of x comma x. And I will return just the entry x. Here we are again. So what do we get from the first one? Well, I can stay here. We have a 3. All right, I like 3. How about here? Sorry? Yes, 2. And you guys are perfectly right. And I don't know if you know why. Probably you don't. The truth of the matter is that it's really dangerous to rely on this kind of evaluation order. So unless you know exactly what's happening, you should probably do this. And now you see that hxx comes before hxy. So that's why this thing here will go to 2 and not to 4. Okay, how about this? List with 4, y list with 2. So, okay, list of 4, fine. This one, nothing changed, I don't think. Nothing changed. How about this? Yes. Okay, very good. Anybody objects? Do you see this has changed? It's not going to be list 2, 4 anymore. This will be list 1, 2. Because it's matched by this pattern. What does this pattern say? It says that the first and the second argument have to be the same. Okay, this one down here will probably stay unevaluated. And this one here will probably still give me an error. Here we go. And I still have a comma. Okay. So where did things change? Here we had a 4, now we have a 2, and here we had a 2, 4, and now we have 1, 2. So this is the important bit. And now, since I like to be messy, I add the third definition just to add some entropy to the system. So first of all, what does this definition do? It takes an x as a first argument, and it takes a list 1, 2. Is there any pattern here? No. So this is a constant, it's a fixed value. And then what it does, there is a list, okay? It just happens to be the same as this one, but there is no relation between the two, okay? And then we have a double brackets, which means I will access this list, okay? How do I access it? With a random number. This is a random integer, so it's either a 0 or 1. But the list, in order to access the list, I need numbers, either 1 or 2. So I scale, I shift everything. And so basically what this function does is randomly accesses the list 1, 2, so it randomly generates either a 1 or a 2. It's a totally idiotic way to generate 1s and 2s, and also it's a totally idiotic function because it doesn't really do anything with x, it doesn't do anything with 1, 2. But I just want to show you the pattern when this function is matched. So we evaluate it, and we go back to the same example. All right, is this going to be matched? So this will still be 3 probably, right? 2, okay. Yeah. This is a random number, somebody suggests. Any objections? No.
It will be pi plus and then a random number out of 1.
Oh, we have a complicated. What are you suggesting?
Pi plus
Huh.
and a random number out of this.
Wow, pi plus random. How do we get there? So a function, by the way, this can only match one of the 3 definitions. There is no mixing. So let's not get too funky. How about this one? Random, okay. How about this one? Well, very good. I like this. So what we should do is to look. So, okay, now I'm not going to say anything. So what do we expect out of this? List of 1 and 2, yes, because the first rule will be matched before the second one.
So why is that the first rule? Not this one.
I'll get to that. How about this one? Unevaluated. Okay, there is no comma, so let's see what. Okay, so far so good. Then we have random, then we have the expected list, and then unevaluated. And now I clear G and I give the definitions in a different order. So what was the last definition now comes first, then XX. And now, okay, let's look at G. What do we expect now? Random number, and it is a random number. Does that answer your question? So it's the order. Since Mathematica right now cannot really understand which one is more restrictive, then the order, the precedence, plays a role. If it's clear, if it's obvious, at least to Mathematica, which one is a more restrictive rule, a stricter rule, then that rule comes first. In this case, that's why I say you should always look at G, unless you really understand what Mathematica is doing. This particular case, that rule has been evaluated first, and it's matched first. So the order is crucial, and I give you another example. Now we have a function. This is a general pattern, and it's x squared. Over the integers, it's x. What is this going to be? Nobody says. Oh, finally somebody says 16. Okay, argue with me. Defend your 16.
ff of x underscore was defined first, and the ff4 fits this pattern.
But integer is definitely stricter. It's more restrictive, right? And it's easy for Mathematica to know that an integer, there are fewer integers than reals. So if we look at this, here we go, integers comes first. So this is going to be a 4. Okay, now I'm going to try the the game the other way around. So I say, okay, now I define integer first, and because there was this switch, right? And then the general pattern later. So anybody protest? Anybody expects a 16? I hope not. It's going to be 4. Okay, but now I'm going to go into something more complicated. So we have some new syntax. That is a conditional pattern. How beautiful are these patterns, right? So this rule now is matched, this pattern is matched only if this condition is satisfied. This is a conditional pattern. And there will be more types of patterns later on. I told you the patterns are, it's a beautiful partnership, and you know, the more you work with them, the more they surprise you. So, if x is less than 4, we have identity. But if x is greater than 2, we get x squared. So everything is it's obvious for x. Should I plot it? No, I'm not going to plot it because I asked Mathematica to plot it. So everything is obvious for x less than 2 and greater than 4. The question is, what happens between 2 and 4? I have two overlapping definitions. Let's see what plot. What? Yeah, okay. It's better if I do this. Okay. So I have one definition up to 4, and then the other definition from 4 up. And in 4, I have 16. So basically, this rule holds up to 4, and then this one here takes over. Okay, now I look at the other way around. Now I define x greater than 2. Notice I just switched the order. Here is less than 4 and greater than 2. Now I just switch the order with g's. Greater than 2 and less than 4. Okay? And now I plot both of them, both the functions, and things have changed. So in this particular case, there is not something more general than the other. It's just the order in which the functions have been evaluated. F and g. So over here, x squared, x. Okay? Yeah?
But this is not the normal way to program a Mathematica, right? You shouldn't do stuff like that if you're writing now a program.
Absolutely, I totally agree with you. But sometimes you're not working in a straight line where it's very easy to see the intervals. Sometimes you are working on an n-dimensional space, and it's not at all clear where how these areas intersect one another, overlap one another. But whenever you can, I agree with you, you should just give two separate definitions. Other questions? No. Okay, let's go back to h. By now you probably have forgotten h, so I remind you what it is. And I want you to guess. This is just to remind what h does. Okay, what's going to come out of the first? Yeah?
A random 1 or 2.
Any other take? What was D? There is no D. That's a good question. Yeah, exactly. It's also who cares, but anyway, the answer is nothing. D is nothing. How about the second one? How about the third one? So we have random, we have error. Random. Yes, it's going to be random. It's just that the first variable will be null, empty. So it's going to be random. So we have random, y, random. Let's see. Random, y, random. Very good. Now, going back to some nasty example that I showed you last week. Remember, we assigned x and then we were trying to replace x, and I said this is something you guys should definitely not do. Let's see what happens here. We assign x, we assign 2 plus a to x. What do we expect from h? For the first one and for the second one? Do you remember I drew here, there was an x and 2 plus x, and I said there is a double arrow. So these two things are indeed the same. So we're going to get 2 plus a in both cases. Okay, let's add some confusion. What does this match? This is yet another definition. What does it match? A list with one element. Okay, I kind of agree with that. So what are we going to get from these evaluations? Let me show you what h is at this point. So first answer is h of d and minus 1? Minus 1, okay. Other takes? Sorry? Sorry? Minus 1 and 3.
Both unrelated. The first one is unrelated and then 3.
Okay. Why is this not a minus 1? Because this definition applies when the argument is a list. See, curly braces. This is not a list, so the two don't match. This will be unevaluated because all the other definitions are for 2 arguments. This is a trick here. It almost looks like we have 2 arguments, but we don't. This is a list, okay? So this is not going to be matched by any of those. But, yeah, but in fact it's not going to be matched by this either, because we have 2 arguments here, 2 entries, and this guy matches 1 entry. So both of them will be unevaluated. Here we go. So let's see what happens down here instead. So one by one. How about this? That's easy. That's also easy. So how many of you think that it's going to be left alone, unevaluated? And how many of you think it's a minus 1? It is a minus 1. It's a list. And what's inside the list? There is a list. But this is one entry. The list 1, 2, 3 is one element. Yeah?
But it's late evaluation also.
It's a what?
Late evaluation.
But why would it be left alone? This matches exactly the last pattern. So we have an open bracket, we have a closing bracket, an opening and closing, and we have one entry, the list. So that will be a minus 1. This is a little more difficult to see, but we have a matrix, and actually it's a list that contains a matrix. So that matches 2, so it's 3 minus 1s. All right. Let's move on to something more difficult. Variable number of arguments. Okay, if h receives only one argument, we return 2x, 2 times the argument, x plus x. So, very good. If h receives 2 arguments, what do? We return a list of the arguments in reverse order. That's easy. So, please, somebody? 6, okay, about this? Exactly. We are actually creating a list, okay? We didn't have a list in input in the arguments, and we created. So we add the curly braces. And over here, what's the same? Unevaluated, yes. Let's see. 6, then we have something that didn't work because I didn't evaluate that. Okay, 6, then a list with the 2 arguments in reversed order and unevaluated. Okay.
I have a question.
Yes.
The lists can have different types.
Yes, absolutely. Okay, now we have multiple patterns, multiple underscores. We have 2 of them. What does this thing match? This thing matches 1, 2, 3, any list of arguments as long as the list is non-empty. So that definition takes a bunch of arguments, any number, and reverse them. In order to revert them, actually I have first to put them inside of a list. So notice that this would not work. Okay, first I have to put them together with curly braces, and then I can reverse them. So here we go. You guys help me. 3 to 1, yes.
8, 7, 6, 5,
Okay, how about this?
1, 2, 3, same.
Okay, and the last one will stay unevaluated. Why? Because it's empty, and I said that the double underscore matches from 1 to any number of arguments, as long as it's greater than 1. Yes?
What would it look like if we had a definition of h of underscore evaluated to L without...
Oh, yeah, that's a good point. This, we would get an error, actually. So,
Why is it 2, 4, 6?
because I didn't clear, and
It's the previous H definition.
yeah, here you go. Because I didn't clear it, that's why. So, since you guys will get this, oh, but I did clear. No, I didn't evaluate it. I see. Here. So I didn't need to clear it. Okay. Okay, I want to show you this one. Yeah, so this is not a list. It's this is a sequence. Basically, it's I really didn't want to explain this. It's a way of putting these 3 objects together in a. They look like a list, but they don't have the square braces. So don't go there. Actually, you might need it if you do a lot of programming, but let's not get there. Okay, and finally we have the triple underscore. And the triple underscore is the ultimate underscore. It matches everything, okay? You cannot go wrong. Triple takes anything you can think of. And in fact, with a triple, we also get the empty list. Over here, what do? I put everything into a list as usual. And then I take the length of this list, and now I want to show the difference. Over here, h of empty was left unevaluated, and here I get length of that 0. Okay. Questions so far? Otherwise, we need to take a deep breath, and we're going to get into something more complicated. No questions?
I have one.
Okay, good.
Is it possible to access the arguments of double underscore or triple underscore?
No.
But I could say if there's a first argument and if there's a second argument,
So
put them together.
what you can do, at this point, the arguments that L is this, let's say, list. It's not a list. Let's call it a sequence of arguments. And the right way to handle this sequence of argument is to put braces around it. Now you have a list, and you can access it with first, last, whatever. So we can say if length of L is greater than 1,
Do you need a slash?
thank
Or
you.
a semicolon?
Of course, yes. Or we can say greater or equal than 2, then blah, blah, blah. Okay? So this pattern catches any length of arguments as long as you have 2 or more arguments, yes? And it will return the second one. It will return, yeah, the second one. Okay. It is possible to assign a name to pieces of a pattern. So in this assignment here, in this function, let's, what is h? No. Should I clear? In this function definition, as I told you before, neither of the arguments is used in the right-hand side. So why don't we do something a little bit smarter or more useful? I say x is an offset. Okay, this is the exact same story, but this pattern here, sorry, this list here, I express it as a double pattern, and I call it pair. Okay, what does this mean? It means as a second argument, I only accept a list with 2 entries. I don't care about the names of these entries. Why not? Because I call the whole list pair. That's a name that I assign to it. And then I use pair, and I extract a number, extract one entry from it, and then I add an offset. Yep.
Could we say off colon underscore instead of off underscore?
Off colon underscore.
Yeah, so we take a, no, colon, not a comma. Yeah.
I guess so. Yeah, I guess so. I've never done this because why wouldn't I do just this? But I guess you can. But I want to show you that you could do the following. A or maybe V1, V2. And then here you say V1, V2. The difference is over here I match the actual entries, and then what do I have to do? I have to combine them again together with the braces. And here I simply assign the pair to the name pair. Yeah?
There is another possibility. You could say pair underscore list with regard that pair has a size of 2.
Sure. Yeah. maybe I should write that so that people, oops.
These pattern conditions, do they apply to one argument?
Ha, 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 ha. That's a very good question. I will get to that later. So you could do this and then say length of a pair equal to, or you could even remove this list. You could do that.
We need to replace the list of V1, V2 with a pair again.
Yeah, of course. Okay, let's take one of these definitions and let's see what happens. So this will return a
Eight or seven.
a what?
Either 7 or 17 or 16.
Yes, random number between 16 and 17. Okay. So, different pattern. Now we have something to the power of something. We have seen this already last week. I call the whole thing x, and if this matches, I will invoke some other function p of x. Okay. What do you expect out of this? P of 8? No? P of 8?
Yes. P of y squared. P of a in the power of b.
I'm pretty happy with these two. I'm not so happy with that.
Well, wouldn't it evaluate 2 to the third to 8 already, and then we have f of 8, and that doesn't make anything?
Probably.
So it will be 2 raised to power 3.
Sorry?
It will be 2 raised to power 3 symbol you can.
Yeah, but 2 to the power of 3, there is no approximation involved. It will just go to 8. So that will not match the power. It will stay f of 8. The other two, yes, they both go to p. Yes?
So is there a way to
Yes,
prevent,
absolutely.
the
Absolutely.
relation of arguments?
Yes. That's going back, going back. That's what hold does. Hold form and things like that. Let's not get into that right now, but that's what hold does. Okay, so now we have a different pattern. Now we are still working with powers, and I call the full pattern x and the exponent e. And then I invoke p of the full pattern and the exponent. So basically I'm using a name for the full object and e just for a piece of the pattern. So what do I expect here? First I have to evaluate it.
One question.
Yes.
Clear f in between?
Can we clear?
Did we clear?
No, we didn't clear f in between. Maybe we should. It doesn't matter. This will overwrite. Okay, what do we expect here? F of 8, okay. Say it again, sorry. Notice that x is the full thing. Mm-hmm. Yeah. I know, guys, this is getting intense, but so 2 to the third, it's evaluated, it goes to 8. So clearly I don't have power left unevaluated. Here, X matches the whole pattern, so pi square, and E catches only the exponent, so pi square comma 2, and same here. All right, now we're getting to something brutal. What does this pattern match?
Any element to take an argument of
Yes, which functions?
H with any argument.
Yes. Okay, and it returns Q, whatever that is.
What was H again?
I think H is nothing, or doesn't. The answer is still okay. The answer is still it doesn't matter. Let's see if I do this.
Because if there were an H for single arguments, it would never.
You are absolutely right. So just to make things clear, so you're absolutely right. Okay, what do we get out of this? Everybody thinks or agrees that this will be a Q. Oh, so we are ahead. Everybody, Q comma Q. Any objection? Yeah. Q comma Q. Okay, let's see. Q comma Q. Very good, guys. But this is getting really tricky now.
So what would happen if you had the function h as one argument?
At that point, well, okay. What do you guys think is going to happen? Yes.
It's going to evaluate 4 cubic.
Yep. 64,
Same with 5.
125.
And then we get unevaluated f of
64, 125. So I don't know. Let's see what f is at this point. Yeah. Okay. So h of 4 now becomes a 64, h of 5, 125. F of 2 entries is unevaluated, so it stays as it is. Same here. Yeah.
So the arguments of f have to be functions. Or I thought maybe the values that those functions.
No. So I am not imposing that this is a function. This is just a name, some h, whatever, square brackets, something, closing brackets. H doesn't have to be a defined function. So if I clear h, this point h is absolutely nothing. So I evaluate this, and then this works. This is purely a matching of the letter h, the square brackets, and whatever value is inside. Yours is a good question. I don't know if we have time, but I'll show you a matching of functions instead. Okay, so let's go to the really nasty one. Okay, let me explain what this is. First of all, ff has 2 arguments. Not too bad. X, the comma separates the patterns, okay? So x is this thing here. But wait a second, it's this thing here too. So now it gets a little iffy. And if by any chance this thing matches, we're not sure what that is, but if it matches, I just call R of x. And now the question is, what comes out of these guys? Yeah.
This is unevaluated, and the second is R of h of pi.
R of h of pi. Can you tell us why?
Well, the first parameter says x has to be of the form h underscore something.
Yes.
And the second parameter is again x, so x is already defined.
Mm-hmm.
So the second parameter must be the same as the first.
Yes, very good. So the first one tells us the shape, the form of x, and it has to be h of something. And we have h of something in both cases here. So we're good. The second argument needs to be the x again. So whatever the first argument was matched with, it has to be replicated here. And this is not the case for the first, but it is the case for the second. So we are going to get evaluated. We're going to get unevaluated the first one, it doesn't match, but the second one goes through, and x is the first argument. Here, the first argument, h of pi. Yeah,
Both of them must be h of the same thing.
precisely. Yes. So you guess. It has to be h of something because of this, and they have to be the same thing because x is the same x. Alrighty, next. I think this was the most complicated, so now you can breathe.
I have one question.
Yes?
In the definition of ff, the h is just a variable, right?
It's just a symbol, it's just a name.
So the h in the definition and the h in the column, it's just coincidence.
Wait.
What would happen if you make that h in the definition a g?
Okay.
I think it still stays the same.
No. It will, no. It matches the letter itself.
Exactly. It's not going to stay the same. It really matches. It wants the argument to be, now it wants the argument to be g of something.
We would still be clear because nobody removed the old definition for ff, so we would still get the same output.
Thank you. That's a very good point. Okay. This is unevaluated. Yes.
What happens if we reverse the order of the parameters?
That's also a good point. So, wait 1 minute. Let me answer your question first. Since you wanted h to be a function, do you guys think I can do that?
Maybe after brackets.
If we lose the g, we could probably
If we used.
remove the g, x column underscore square brackets of underscore.
So you say that this would work. But it's a pattern. I can always assign a name to it. So this is equally fine. The question is, can I do it? Why not? It's a symbol. So now I cleared this thing, I evaluated, and now this is going to match. See, it went through. I will give you another example like this later. Now you wanted to reverse the order. So let's go back to this, x, comma. The order doesn't matter. This is very important. In the pattern, the order doesn't matter. Yeah?
Well, this time the x can be matched to the first argument in whole, and then you can look if the second argument has this shape. Can you understand this?
Sure. But the thing is whether the match goes through or not. So how Mathematica does the matching, we don't know. This is besides us. It's probably an NP-complete kind of problem. I'm not sure. Yeah.
So now it just matches the number of arguments.
First it matches, wait. First, it matches the number of arguments, yes, and then it matches the structure of them. Yeah.
Could we use a double or triple underscore inside the h of instead of the one underscore to match any argument, any number of arguments?
Sure, sure, sure. It's no problem. You can put here double, triple. Sure, it's no problem. Okay, let's go to matrices. So we clear F. What do we have here? We have a matrix. It's a 2 by 2 matrix. How do I see that it's a 2 by 2 matrix? Curly braces, list, other list, same length. So clearly it's a 2 by 2 matrix. And I call the whole matrix M. In addition to that, I say that the top right corner, the top right entry of the matrix must be 0. I fix it to 0. So my matrix is pattern, 0, pattern, pattern. The full matrix is called M. And then I assign names. This is an A, this is a B, this is a C. 0 doesn't have any pattern. It's fixed. It's a constant. And if this is matched, what do I return? The list B and C. Yes. Alternatively, we still have a matrix. It's still 2 by 2. There is still a 0. I call the matrix M, and I return the second entry of the matrix. So again, I return this object here. I don't have a way of expressing it, but who cares? I didn't use B and C, so this is the exact same definition. How about this?
This is, yeah,
Same, right? I have a matrix. I only say that the top right entry has to be 0. Now my M is not the full matrix, it's only the second entry of the matrix. And so I return M, I don't return M of 2. Is that scary? Okay. Now I have another definition that is a determinant of a 2 by 2 matrix. So, what do we get here? Clearly the determinant, because there is no 0 in the top right entry. Now what? This matches both of them, right? So we do. So the answer is a B, very good. And this, there is no 0, so it's going to be the determinant. Should we stop here? Yeah? Do you guys have questions so far?
Do people use mathematical in such a way?
Yes.
What's the difference between the question mark and the double slash semicolon?
Yeah, I didn't want to get into that yet. Normally, a question mark is just something that returns true or false on the X. And this thing here is a more complicated function. And test function is normally just on one argument. That introduces a more complete test. But there is not really, I wasn't able to find a big difference. So you see, now you can have a condition on all of those guys. Also, these slash semicolon, you can put it in different places of the definition. I will show all of this. It's all down here. So let's continue on Thursday. See you guys.